Hello, everyone. Today we are going to talk about what is data. This is part of our lecture on AI for cybersecurity. For us, as you mentioned, to learn about how to use the principles of machine learning and AI in general to advance cybersecurity. First, we need to understand how AI works and what is AI. So what is data? So let's take a look at the data here. All right. So here are some examples, or this is an example of a table of data or a data set, as we call it. We're looking at this is housing prices, house per square feet. So we have 523, we have 645, 708. Number of bedrooms is 1, 2, 2, 1, 1, 2, 3, 4, 4. And then the price by hundreds of thousands. So this is $100,000. If the size is 523 square foot or square feet, then it's worth $100,000. This is data about the housing market. Okay. On the right side, we can see images of cat. You can see an image of a cat. We can see a bike. See an image. You can see a car. So we are going to label these images, right, to be able to feed them and train our AI models. So this is a cat. This is not a cat. This is a cat. This is not a cat. Okay. So those are examples of data. Acquiring data. Where do we get our data from, our data sets? There is also manual. There we have manual labeling where people actually are called labelers. So we can find labelers to label our data set. So you see a picture of a cat, they will label it as cat. They will see a picture of a bear, which is not a cat. They will say this is not a cat. And then they will see a flower, sunflower, that will be not cat. From observing user observations as well. So we have a machine, we have the temperature in Celsius, we have the pressure, we have the machine fault, and also we can download it from websites or partnerships. Sometimes there's proprietary data that you can get from partnerships, but we have to be careful about that, or we might get it from publicly available resources such as Kaggle, Hugging Face, GitHub, etc. There are a few places. Use and misuse of data. Don't throw data at an AI team and assume it will be valuable. This is a very accurate statement. Data needs to be clean, it needs to be processed, it needs to be converted into a format where ML models can understand and process. We can't just get a bunch of data and throw it at an AI model. So maybe you can take a look at the example of data here. This is an example of a data set called diabetes prediction data set. This is a publicly available data set from Kaggle. And you can see here there are thousands of records here, and we have all these features. You go to the beginning of this, we have these columns. Each one of these columns will represent a feature in an ML model. We start with the gender and then the age, hypertension, 0 or 1, heart disease, 0 or 1, smoking, never, body mass index, HbC1 level, blood glucose level, etc., etc. And we have maybe one more feature. Okay, that's it for the features. So this is an example of a good data set. This is a clean data set that we can use to feed our ML model. So each one of these is considered a feature. Some of these features will be more important in determining whether somebody has a diabetes or not. Maybe the age, maybe the gender, maybe if they are smoking. We're looking at the smoking history column here. We can see some of them have never smoked, some of them is no info. Wherever we see no info, this may not be good information for our model because it doesn't really help our model. We need to know whether or not they have a smoking history or not, meaning have they smoked in the past or not. We can see also current, meaning somebody is currently smoking, which is a male of 76, right? This is useful for our ML model. But if we say no info, that's not very useful. So sometimes you may have to remove these or do something about it to make sure that everything we are giving our ML model is clean and is useful. Okay. Data could be messy. If we put garbage in, we'll get garbage out. There are some issues with or problems with data, such as incorrect labels, right? So here, this is an incorrect label. Number of bedrooms says unknown. This is not good or missing. So this is a missing value. This is a problem with data. Again, as we saw with the diabetes data set, it says no info, that's missing value, that's no good. Or if the label is incorrect, meaning if it's a cat and says it's a dog. Multiple types of data. If we have images, audio, and text, this makes it even more difficult and more messy. Some terminology of AI. We have machine learning versus data science. If we're looking at the home prices here and the size per square feet here, number of bedrooms, number of bathrooms, renovated, yes or no, the price by hundreds of thousands. Running AI system like website or mobile homes with 3 bedrooms are more expensive than homes with 2 bedrooms of a similar size. Newly renovated homes have 15% premium, right? So the art and science of extracting insights from data, useful insights from data, is called data science. We have this data, right? This is part of a data set. When we are saying, okay, homes with 3 bedrooms are more expensive than homes with 2 bedrooms of a similar size. And this is a 3-bedroom home, right? And the size is 645 here. But if we have a home with 2 bedrooms, sorry, this is the number, this is 3 bedroom, and this one is 2 bedroom. Of course, this one would be more expensive because this is 300,000, this is 200,000. This is an insight that we are able to glean from this data set, right? Or part of the data set. This is data science. When you say newly renovated homes have a 15% premium, this is newly renovated, so it has a premium. This is all data science. We are extracting insights from the data. So machine learning is the field of study that gives computers the ability to learn without being explicitly programmed. Arthur Samuel, 1959. Data science is the science of extracting knowledge and insights from the data, as we saw about the house price. So something to keep in mind that when we are using data science, we're not really using any machine learning model. We're not really teaching computers how to think, right? We're not giving them the ability to think. Machine learning is all about making computers learn in a similar manner to the human brain, okay? So with data science, we're not using any models. With machine learning, we're using models and you're teaching them how to think like humans without explicitly programming them. We want them to learn from the data rather than we rigidly program them. Deep learning. Here is an example of a deep learning or neural network. On the left side, we have inputs. In the middle, we have neurons firing off, and then the output is the price. And of course, there's a big mathematical equation here in the middle. So this is an example of a deep learning or neural network. We have the size of the house is one of the features, right? And then we have the number of bedrooms, the number of bathrooms, newly renovated, yes or no. And as we can see here, each one of these features could be correlated with other features, right? So the size could be correlated with the number of bedrooms and the number of bathrooms. And same thing, newly renovated well, might actually increase the number of bathrooms, for example. And then the output is the price. So all of these are input features, and the output is one feature. And there's a big mathematical equation in the middle to make the magic happen. So neural networks were originally inspired by the brain, but the details of how they work are almost completely unrelated to how biological brains work. AI has many tools. We have machine learning and data science. We have deep learning or neural networks. We have other buzzwords like generative AI and supervised learning, reinforcement learning, graphical models, planning knowledge graph, etc., etc. The list goes on and on. What makes an AI company? A lesson from the rise of the internet era, shopping mall and website, internet company. You can make an internet company. In the AI era, any company plus deep learning does not equal an AI company. We have to be strategic about where we get our data from. We have to have a unified data warehouse, pervasive automation, and new roles such as ML engineer and division of labor. On the other side, during the internet era, we had A/B testing, short iteration time, the decision making pushed down to engineers and other specialized roles. AI transformation, we can execute a pilot project to gain momentum, start small, and build an in-house AI team first because it might be too expensive for a small startup to have to maybe hire ML engineers or AI teams, provide broad AI training. Of course, training is important. And we have to have an AI strategy and internal and external communication. These are all important aspects for AI transformation to have. What machine learning can and cannot do? So we have supervised learning as we've looked at in the past, where we have inputs. A is the input, B is the output. If we have an email, we would like to classify it as spam or non-spam, right? If we have an audio file, we would like to convert it to a text transcript. And this would be the task of speech recognition, right? Anything you can do with 1 second of thought, we can probably now or soon automate. Wow, this is amazing. So we're moving towards automation. Self-driving cars, chatbot, sequence of words, the next word, visual inspection, image of a phone, defect or not defect, etc., etc. So these are just some of the examples of supervised learning, which is one of the most widely used techniques of machine learning. This is what machine learning can do. What machine learning today can do and cannot do, again, predicting the stock price. It can try to predict the stock price. What makes an ML problem easier? Learning a simple concept and lots of data available. So what has really helped revolutionize ML in the past few years is that we have lots of data right now. Data sets are available publicly to people, so anybody can use them, and there's a lot of data out there. And learning a simple concept is not hard. We also have the compute power. In the past, we didn't have the GPUs. So now that we have the compute power, we have lots of data, and we have the expertise. I think all of these coming together have helped revolutionize the field of ML. What is an AI? More examples of what machine learning can and cannot do. Okay, let me switch to other slides here. Okay. So self-driving cars can do. So we have self-driving cars on the road, as we know, but they're not been widely used yet. So we can use ML for self-driving cars. We can use vision models for self-driving cars. But ML cannot do these tasks. It cannot stop, it cannot serve as a traffic officer. It cannot hitchhiker. It cannot bike, turn left signal. Cannot do this. So because we need data and we need high accuracy for these tasks. So on the left are things that machine learning models can do. On the right, examples of things that ML cannot do. X-ray diagnosis, what AI or ML can do, diagnose pneumonia from 10,000 labeled images. So if we have 10,000 labeled images, and each image will have a label, maybe pneumonia or non-pneumonia, positive or negative, right? 10,000 labeled images. This may not be enough, but it's a good way to start an ML model, right? So imagine you have an ML model that's used in the healthcare industry with a task of diagnosing people whether or not they have pneumonia. So if they have pneumonia, the label or the output will be positive. So if it's positive, that means they have pneumonia. If it's negative, that means they don't have pneumonia. Okay. And then what ML cannot do, diagnose pneumonia from 10 images of a medical textbook chapter explaining phenomena. So it cannot diagnose pneumonia from 10 images of a medical textbook chapter explaining pneumonia because 10 images is not enough. We need training. We need data. These ML models are hungry for data. They need lots of data for training. They cannot learn patterns and make predictions by just looking at 10 images. You need to show them thousands of images. As you can see here, there are 10,000 images. And in some cases, we have to show them hundreds of thousands of examples or images or data points before they can learn how to draw patterns and make predictions. It's all about learning patterns and making predictions. So these are just, again, examples of what ML can and cannot do. Strengths and weaknesses of machine learning. ML tends to work well when learn a simple function or concept when there is a lot of data available. When there is a lot of data available. So these are strengths of machine learning. ML tends to work poorly when learning complex functions from small amounts of data, as you mentioned. We want our ML model to be able to predict whether somebody has pneumonia or not, and we only show them 10 images from a medical textbook chapter. That is not enough. It will perform very poorly. It's asked also when it's asked to perform on new types of data that it learned from. New types of data that it learned from. So when we show our models new data, when we deploy them to the real world, they might make mistakes. They might perform poorly. Non-technical explanations of deep learning. Again, housing prices, demand, and price. We have all these input features. This is the feature space on my right. All of these are input features. And the neurons will be firing off. So we would like to predict the demand for housing price, for housing maybe. So again, if we were to predict the demand using ML model, we have to provide features. The features, input features are the price, the shipping cost, the marketing, and material. And then the ML model will be able to predict whether the demand is there or not, whether there is demand or there is no demand. Maybe yes or no, 0 or 1, or maybe positive, negative, or maybe even logistical regression. Demand is high, is low, is medium, etc. So we'd like to predict the demand. Again, this is how a neural network will work. Price, shipping cost, marketing, and material, all of these are input features. and they will lead to the output of the demand. There are neurons in the middle that are firing off. So the price, right, is correlated to the shipping cost, and it's also correlated to the material, right? And then the cost is correlated to the shipping cost is related to the price, which is also related to the material. The marketing is related to the price, to the shipping cost, and to the material. To the price. So sorry, marketing is only related to price and material. It's not related to the shipping cost here. This or it might be in some cases. Okay, and the prediction is the demand, whether or not there is demand. Non-technical explanations continued. Face recognition. This is how we recognize the face, and we have an array here, numbers. So for face recognition, this is what happens. The input is the face of a person. It goes through a neural network, and this is specifically a face recognition or image recognition, a face recognition system, vision model, and we'd like to provide their identity, who that person is, right? So this is what a neural network could do. Okay, so this brings us to the end of the session. Thank you.